Welcome to another EclipseStore fundamental training today. Before I hand over to Marcus, I give you a short introduction to the most important stuff of the training. One is this training will be recorded, so that means that you will get access to the video afterwards, and yeah, you have to know that this training is recorded. Let me introduce myself a little bit. I think Marcus will do that later on. So my name is Kuemmel, and I'm a developer advocate on MicroStream EclipseStore. Mostly I'm a trainer and conference speaker, and at the moment I'm the project manager of the cluster development of MicroStream. So let's move on. This is the timetable for today. So we start with lesson 1 with Marcus with a small introduction or medium introduction to MicroStream or EclipseStore. Then we move on to the coding stuff on lesson 2 and 3 and 4, and then we have our last lesson is a Q&A session with me and Marcus, maybe, or only with me. Let's see what happened then. During the time we have a small break on 6:30. I think that's it. We have some further information, as I said, but you will get access to the recording afterwards. You will also get access to the code of the training. If there are any questions, so feel free to ask them as much question as you can. There are some links I want to share with you. Most of the projects we used during the training are available on my GitHub account, MicroStream. Also the documentation, training examples, you will find everything here in that GitHub account. And you will also get a certificate after the training. At the end of the training, I will share this link again. Here you can add your registration, and then you will get a certificate of the training itself. So as I said, the topics for today are a small introduction to EclipseStore. Then I want to show you a small performance demonstration, how fast and efficient is EclipseStore. Then we go on with a quick demo, so you can lean back and just have a look how it works, basically. Then I want to talk about a little bit a proper data model. And then we do together a step-by-step configuration of EclipseStore. And after that, at the end, we do a small CRUD operation stuff, and we talk about queries and Java Streams API, for example, because we use, instead of using SQL, we mostly use Java Streams to get our data. So that's a very important topic of EclipseStore. Yes, that's it for the topics for today. And now I will hand over to Marcus, and let's start with his presentation.
Thank you so much, Christian, for your introduction. Please let me, you have to allow to share the screen, Christian. Okay, right.
You should be able to share.
Okay. Hello, everybody, and thank you for joining. Welcome to our today's training. I'm happy to be here to make this short introduction. I hope you can understand me and it's not too noisy. So I'm here at EclipseCon right now. This is our annual developer conference organized by the Eclipse Foundation. So, today we have our very first, so Christian mentioned, so said, welcome to one of our training. So, but actually this is the very first EclipseStore training, right? So this training is all about EclipseStore, because now EclipseStore, MicroStream is now EclipseStore, and it's an official Eclipse project. we're still waiting for the final release, actually. So we have split the MicroStream project into two Eclipse projects. So one is called Eclipse Serializer, which is the core of always the core of MicroStream and EclipseStore, and the second project is EclipseStore. So I like to give you a short overview about the functional principle of EclipseStore, how it works basically, and then I will hand over to Christian, and he will introduce you to how to get started coding with EclipseStore. So if you have any questions or any doubts, or so if you're confused about the functional principle, please use your chat or use our chat or your microphone to ask questions. So let's keep this interactive. Then we'll be able to answer hopefully all of your questions. So with EclipseStore, we introduce a completely different approach of how to store Java objects, how to store data in Java. And the initial idea actually is database-less data processing. And so data should be processed by the programming language, by Java, so that you can focus on business logic and how to build your application in Java. So you not have to care for persistence, how to store your object in a database. So this is this was the vision of this project, and the main benefits of this approach are, so it enables to process data in memory with pure Java concepts, and Java in memory is around 1000x faster than a comparable database query. So one benefit is definitely performance. Another benefit is storing data in a cloud without the need to use a database is around 99% cheaper than a database as a service. So cost savings in the cloud. And third is simplicity. So it should be much easier to implement database applications in Java when you don't have to care for persistence. The big question is this really only a vision, or is this really true? So EclipseStore is not a vision anymore. It's not a prototype. It runs in production, so this concept really works, and it runs in production. So many companies use EclipseStore, or previously MicroStream, in production already, and more companies are interested in using it. So in a nutshell, how does it work? So EclipseStore is a Java native micro persistence. We call it micro persistence because it's really small. So it's micro. Everything is small, but it works great with microservices. We call it Java native because it is really it feels like a part of Java. So it should feel like it's a native part of Java. It's a persistence layer that runs within your JVM. So it runs within your application or your microservice. So you can use it with microservices or also with monolithic applications. And it enables you to store any object graph. You can store simple objects, you can store simple lists, but you can also store very complex graphs of any size, any complexity. You can not only store the entire object graph, you can also store only parts of the object graph, subgraphs, and in practice, mostly you will deal with subgraphs and lazy references. And you can store all these in a binary format into any binary data storage. And vice versa, it allows you to load any kind of persisted object graphs and restore it in memory. And you not only can load the entire object graph, in practice, mostly we will load subgraphs. So by using lazy loading, so to restore subgraphs dynamically in memory at any time. And the loaded object references are automatically merged into your object graph. So you just have to call get methods, and then you get the object either from the JVM if it's already in memory. If it's not in memory, EclipseStore will fetch the object reference from disk and gives you the object reference like magic under the hood. So EclipseStore does the job under the hood. You cannot. So it feels like you get the object from the JVM directly. So the loaded object reference is automatically merged into your object graph, and your object graph becomes your in-memory database. So then it combines this high-performance searching in memory by using Java Streams API with transaction safety, data persistence. So each store operation is an atomic all or nothing operation that is transaction safe. So we have transaction safety. And of course, traditional database is not required anymore. So it's really database-less data processing. I mentioned the three major benefits are high speed in-memory data processing, lowest data storage costs, and simple implementation. EclipseStore is open source, of course, under the EPL, Eclipse Public License. And the Eclipse Public License allows you to also write, to use it in commercial software and closed source software. So you can use it not only for open source. So this is the difference to GPL. So Eclipse Public License allows you really similar to Java, which is under GPL with class exception. It allows you to write and produce commercial software as well. So now we are super happy to announce that microstream serializer is now called Eclipse Serializer. This is very, very important for us, important milestone. The final release is now available. And this is important because of Eclipse Serializer is now an Eclipse project, and it's now even more open and supported and accepted by the community. With Eclipse Serializer, we create the binary format we store the data in a binary format, and this is created by the Eclipse Serializer. And it's a part of and a dependency of EclipseStore. Unfortunately, EclipseStore is not available as a final release today, so hopefully we can release it tomorrow or hopefully this week. So it was scheduled actually also for this week at, during Eclipse Con. So let's see what happens. The nice thing here is EclipseStore comes with only one dependency, and this is Eclipse Serializer. So no more other dependencies. It's very easy to use it, and so there are no superclasses. There are no interfaces you have to implement. So this is really straightforward. And we also work on a standard. EclipseStore, or the functional principle of EclipseStore, should become a standard similar to the JPA standard, and then EclipseStore will become the reference implementation for this new standard. We built this standard within the Eclipse Foundation. All right. So EclipseStore, or previously microstream, is already used by frameworks out there, like so the Helidon guys. Thanks to the Helidon team, they were the first who integrated microstream with their microservice framework. So now it comes with Helidon. It's also part of Micronaut. So Micronaut provides a beautiful integration with microstream, or now EclipseStore, and other frameworks also will follow, and we provide integrations with all of these microservice frameworks out there. It's not that new. This project was started in 2013 actually, and almost 2 years later we used the framework in production for the very first time. Then we recognized, so hey, it works great and the performance is great, it's easy to implement, so we have to build a product, or we have to create a framework that every developer can use the functional principle of this concept very easily in projects. It took us some more years to build a convenient framework, and as I mentioned, now it's available as an Eclipse project. So currently, MicroStream is available in version 8, and the EclipseStore version 1 final release will be compatible with MicroStream version 8, and there is also a migration tool available. So migrating a MicroStream application to EclipseStore will be really easy. Next version, EclipseStore 2, will be the only implementation. So we will stop developing, further developing the MicroStream open source project. So we will really focus on EclipseStore. So it's another overview. So as I mentioned, we are creating a standard at the Eclipse Foundation for this functional principle. So we describe the functional principle and standardizing the functional principle to allow other vendors build similar frameworks. EclipseStore should become the reference implementation. And today, this framework, this is very important. The framework runs on a single JVM. It's a single JVM storage. On top of that, we provide a cluster solution for building distributed EclipseStore applications. And with MicroStream, we provide this cluster, and we provide the cluster solution on premise or as a managed cloud service. So why should we care for another persistence? So I like to talk a little bit about the functional principle of what we have today in Java and why we have challenges with persistence. So in Java, of course, everything is an object, and everything is object-oriented. The problem is all databases out there are incompatible with the Java object model, because we have no databases who are able to store Java objects. So with relational databases, which are the standard for decades, we have tables and we have records. So it's not possible to store complex Java objects seamlessly in a relational database. This is called, so we have impedance mismatches here. There are further impedance mismatches. So it's because of the object model can be very granular and much more granular than the relation model. Subtypes are not possible in the relational model, and so on. You can navigate through an object graph very easily because all objects are connected via their object IDs internally. This is not possible in the relational model. We need SQL query language. And also we have these data type differences. We have some primitive types in Java, and we have a lot of data types in the relational databases. So we have a lot of mismatches here. So, and we have to care for fixing these issues. And it's actually the same with the NoSQL databases. Now the NoSQL databases focus on different data structures. So they introduce new data structure like the column stores or JSON, XML. We have the graph databases, object-oriented databases. And by the way, these object-oriented databases are also incompatible with the Java object model. And now we have the vector databases. And all of these databases are also incompatible with the Java object model. So in practice, we need a kind of like mapping in between or a data conversion under the hood through actually every single read and write. So to be able to transform our Java object in something we can store in a database. There is a standard in Java called Java Persistence API or Jakarta Persistence API, and Hibernate is the de facto standard here. Unfortunately, this mapping and data conversion behind the scene leads to latencies. So objects have to be generated behind the scenes, or data structure or data have to be converted. So this leads to expensive latencies. And the frameworks are really complex. And so this is the reason why we, here you can see impedance mismatch. You can read about this in the internet. There are great articles, easy to understand. And to accelerate database applications in Java, we are used to use caches. So this data conversion or mapping slows down our queries. Okay, then we are used to add a local cache. And the core problem of this incompatible data structure leads to many further challenges we have to solve in Java. So, okay, we add a local cache to accelerate our applications. This works great as long as we have only one Java process. As soon as we have a distributed application, we run multiple instances of our application or microservice, then there are some challenges as well. So because of if some data or some objects are changed in one of these instances, and we store the object in the database, then of course this instance is in sync with the database. The problem is all of the other application nodes or microservice instances are not in sync with the database. So the problem also was fixed by putting the cache between the application nodes and the database. And so in many applications, we see these distributed caches, so like Redis. So then we have the cache in between the application and the database. And if we have increasing loads on the database, of course, we are used to run multiple instances also of our database. So then we have a database cluster and replication. So we can see we have 3 clusters running, and sometimes we use searching servers additionally for accelerating queries, something like Elasticsearch, for instance. Then actually we have 4 clusters running just for initially we want to store some data in a database or persistently on disk. So which means the complexity of our system increases more and more. It's only because we wanted to store some objects persistently on disk. And databases are very expensive in the cloud. So why? Here's an example. For instance, AWS PostgreSQL as a service. It depends on the machine you use. So for instance, if you have a 4 CPU machine, 16 GB memory, it costs around $3,000 per year, depending on the configuration of your server. So if you need more database nodes, your price will double or triple. 6 nodes will cost you then around $18,000. So this is the reason why databases are very expensive in the cloud, because we need storage and we need CPU power, and computing is expensive. storage is cheap. There is an alternative provided by the cloud vendors. The cloud binary data storages like AWS S3, they are much cheaper because we only need storage. 250 gigabyte AWS S3 costs only $70 per year. So this is more than 99%. This is almost 99% cheaper than the comparable database as a service. Now, imagine we could now store our Java objects seamlessly in a cloud binary data storage. And we don't need a cluster. So the great thing here is the cloud vendors, they care for 99% uptime. They care for data center replication. You don't have to care for how to replicate your storage. So all in all, $70 per year. That's great. So now imagine there is a solution where we can combine the performance of the JVM, the power of Java, with cheap cloud data storage. And this is what we're doing with EclipseStore. Why should we actually search data and process data with Java? It's because of Java is really fast. So we have the great JIT compiler in Java, and with the JIT compiler, Java programs are accelerated through runtime, and it even can outperform C applications because of our great JIT compiler. So database operations can be executed in microseconds in memory by using Java concepts only. And this is really fast. The databases are also limited. So it's because of their data structure. So for instance, if you want to deal with sensor data, then database vendors provide you a time series database. If you have complex data structure, yeah, you can choose between different solutions, but probably there is a graph database, and they were invented for dealing with very complex data structure. But the graph databases vendors, they would say, oh, if you have some sensor data, you should not use us. So use a time series database. Then we have the document-based databases and the relational databases. So we have multiple different database systems, and they were specifically built for specific purpose. In Java, we have a multi-model data structure from the beginning. So we have object graphs, and yeah, we are able to store single values. We can store a simple list for our sensor data, but we also can work with collections. We can build complex graph structure with circular references. So everything is possible in Java, and we also can deal with vectors. So Java is already a or provides already a multi-model data structure, the object model, and Java provides a great query language for searching object graphs in memory, the Java Streams API, and searching complex object graphs. So even with millions of nodes in your object graph in memory, and even if you have terabyte data in memory, it will take only microseconds, or mostly will take only microseconds to search an object graph. And we talk about microseconds here, so which means microseconds, and in comparison to, we talk about milliseconds when we talk about databases. So we have a factor 1000x faster when we use Java Streams API and searching object graphs in memory with core Java. That's great. So here are some numbers, and you can see that the numbers are really huge. So in memory computing, we talk mostly about nanoseconds. So assembly instructions are executed in nanoseconds. When we fetch data from from a memory, from a DRAM, it only takes some microseconds. And when we read data from a disk, this is around 1000x slower. And databases mostly have must access fetch data from disk, or very often, or also use caches to accelerate data processing. So there is a functional principle, and the functional principle is well known for many years. It's called system prevalence, and this functional principle is already used by very successful, used by banking companies or gaming companies, because banking companies very often need the best possible performance. Also, gaming companies need for their online games best possible performance. So they use this functional principle, and the principle is simple. So it says keep your data in memory, search data in memory with your programming language, and it will be fast enough. It will lead to a simple architecture, because you don't need all of these data technologies like distributed caches, in-memory data grids, databases. So everything is in memory, everything is fast, everything is built in your programming language, object-oriented. That's great. So and yeah, store your objects persistently on disk. Keep the hot data in memory, and store your objects persistently on disk by using serialization. So it sounds very simple. The problem is, should I really keep the whole database in memory? Does this mean we keep now all data in memory, so we are limited to our memory size? Should we really create a snapshot of the entire system state when we need persistence? No. So with EclipseStore, we have now a framework that enables you to just create a snapshot of the changes on your object graph. So we only create a snapshot of the changes, and we keep only the hot data in memory because we have lazy loading. And we combine this functional principle with transaction safety. So how does this work? So let's have a look inside our database. On the left side, we can see our Java instance. We have a JVM. We have the object graph in memory. We have an application in Java. And here we can see a database server. So with database server, we have a database management system under the hood. We also have a lot of memory in our database server, obviously, because the database also cache data, keep the hot data in memory. Sometimes we have some stored procedures, stored functions, and of course we have storage. Now, we add here some data conversion, or we add a mapping framework like Hibernate and a local cache. So what now we do with EclipseStore, we replace data conversion or object relational mapping with EclipseStore. So now EclipseStore runs within our JVM process. We keep the data in memory. We use the object graph in memory as our in-memory database. So we have data in memory already. We don't need a local cache anymore. We can skip the local cache. And we only use storage. We don't need a database system. We don't need a database server, because now our application logic becomes the database management system, and our application logic cares for everything else, how we operate on our data objects. So we don't need the database management system anymore. We just keep storage. We just need storage. That's it. And the architecture becomes really simple. hopefully. We have some performance demo. They show how fast it is. So Christian will show this performance demo later. But how does this work with a distributed application? Here we can see a distributed application or a distributed microservice. So we replace the nodes with EclipseStore nodes. And then we provide replication. So we are now able to replicate the system state of our JVM. So we are able to replicate the object graph through hundreds, even thousand JVM processes. And we keep hot data in memory. Each node keeps hot data in memory. So we don't need a distributed cache anymore. So we can skip the distributed cache, and we replace the database cluster with a blob store like the AWS S3. And then we have plain architecture also for distributed application. And this functional principle also works in production already. So this is not prototype or a concept that we have planned. So this works in practice. If you have some questions about how this cluster works, please ask your questions directly to Christian. Christian is not only one of our developer advocates, he's also the lead of the cluster project. So if you have any questions, ask Christian, he's expert. So in comparison, we get out finally a really simple architecture, and it increases our productivity. It accelerates the time to market. It's much easier to test, to deploy, to maintain complex business applications in Java. This is the real goal. If you run an EclipseStore cluster like this, these cluster nodes would be stateful. So, but if you want to build stateless applications, you want to combine this with AWS Lambda, for instance, so with serverless functions, you can do this as well. Then you can run an EclipseStore cluster, and you can query the EclipseStore cluster by using REST or GraphQL, and then you can build also applications or microservices with other programming languages, or create stateless instances of your application or microservice and query the EclipseStore cluster. So this is the functional principle. The EclipseStore cluster itself can be implemented, of course, with Java and all JVM languages. And we also have connectors to all important or all major data storages. AWS S3 is recommended, but you can also use it with Microsoft Azure Cloud, Blob Storage, Oracle Cloud, IBM Cloud is new. And you can even use databases. We have really connectors to classic databases. Why? It's because also traditional databases are able to store binary data. So basically, you can use it. It runs on wherever Java runs. So it runs also in containers, in Kubernetes pods. It runs with Graalvm native images as well. No problem. It runs also on Android. So it's the same API available on Android. And the only requirement is Java version 8. It runs with all JVM languages, and use cases are you can build microservices, serverless functions, analytic applications. There are no specific use cases, so we are not saying that if you have some sensor data, then it's great, or you have only complex data like a complex graph, use EclipseStore. I mean, we can deal with all data structure in Java, and we provide persistence for your data structure, which means you can use it with vectors, and then you can use it, so it will work. So it's not built for a specific use case or a specific industry. The core of EclipseStore is Eclipse Serializer. So we built a serialization from scratch. It's because of Java serialization is very limited. With Java serialization, you can only use classes when you have to implemented the interface serializable. Then you can you'll be able to store data persistently on disk. You cannot store complex object graph with circular references. Its Java serialization is known as insecure, so there are a lot of disadvantages. This is the reason why we built Eclipse Serializer, a serialization from scratch that works fundamentally different to the Java serialization. It does not use reflection to create the objects. So this is one of the biggest vulnerability of the Java serialization is because of the objects are generated dynamically by using reflection, and this is a security leak. Eclipse Serializer works fundamentally different. So with Eclipse Serializer, we map the objects directly into off-heap memory, and provide to JVM the objects. So JVM does not care for creating the objects. So it's cannot be hacked by deserialization attacks. And Eclipse Serializer can deal with even most or very complex data structure. So you can have millions of nodes or billions of nodes with circular references. The more complex your object model is, the more efficient Eclipse Serializer works. It can deal with all Java types, almost all Java types. So the only thing, all objects that can be recreated through runtime can be persisted. So it cannot store, you cannot store a thread, for instance, but everything that can be recreated through runtime can be persisted by EclipseStore. So Eclipse Serializer is the heart and the core of EclipseStore and the only dependency. I mentioned already that we have another implementation for Android. It's pretty much the same API. Then there are so many additional features we have in EclipseStore because it's not only serialization. So with serialization, there are further challenges. For instance, what is if my classes change? Then I'm in trouble. No, you're not. For this scenario, we provide functionality called legacy type mapping. It cares for your class evolution. So it's solved through runtime. You don't have to refactor your code. So this is very convenient solution. Christian will tell more about legacy type mapping, I guess. Then we have we store the objects appended to the file storage. So we never override data. So if you create a new object and store an object into the persistence, it gets stored appended to the file storage. If you change an object, we also store the object appended to the file storage. So we never lose data, and each store is an atomic all or nothing operation and transaction safe. So if you change classes, and then the storage will grow more and more. So this is not that great. So for this scenario, we provide this file system garbage collector. It removes your legacy objects from your storage, so you can decide whether you want to keep your legacy objects in the storage or not. We have a file system abstraction, so you can store your objects wherever you want to store it. You can store it in Kubernetes or in persisted volumes. You can store it in S3, for instance, or you can store you can use a plain file system to store your objects, so you can store it almost everywhere. We have database connectors. We have a REST interface, so MicroStream or EclipseStore is not a black box. So we have a REST interface, and the REST interface gives you access to the persisted data. And on top of that, we have a graphical user interface that allows you to browse through your storage data very easily. We have a CSV export for migration. We have native backup functions and also converters where you can import and export your persisted data. And of course, a cluster solution. And all of this is EclipseStore. There are some rules and challenges, of course, also. You should learn more about that. So keep in mind, a database server works fundamentally different from the microstream or the EclipseStore approach, because a database, a classic database, runs on a remote server. The database is stored on a remote server, and queries are executed on a remote server. With EclipseStore, your database is located within your JVM process. So, and searching object graph is executed in the same JVM process as your application. So your database is an embedded database, and we only have a storage. So you cannot. So you have to think different from the traditional database server paradigm. You cannot browse or search the storage. So we cannot execute some queries on the storage. This is not possible anymore. So because there is only storage, there is no machine anymore. So you have to search within your application. This is very important. If you have enough memory, great, use it. So we save a lot of machines. You can now spend your machines a little bit more, or yes, can use a lot of more memory. The more memory you have, the more efficient microstream or EclipseStore approach will be, of course. But this is not needed. So you also can have a terabyte data storage, and you only have limited memory. For instance, 4 GB memory. And this will work because we have lazy loading. We just load the hot data into the memory, keep hot data in memory, and the engine or JVM cares for memory management. So, and you just have to call the get methods. Anything else is done by the engine behind the scenes. But you have full control about your lazy references in memory. So you can define timeouts, you can clear your lazy references when needed, or let the JVM remove objects that are not needed from memory. So you have influence to almost everything, but you also can let the JVM do the job. All right. Challenges with EclipseStore. It's built for Java developers. I hope all of you are Java developers. If not, if you have some Python or some .NET developers with us tonight, please enroll for a Java course. It's a non-SQL technology, so it's not comparable to. I don't want to say it's a NoSQL database. It is not. It's not a database at all. But it's not a SQL technology, so it belongs to a NoSQL market. So there is no SQL support, so you cannot execute SQL. You have to use Java methods for loading your subgraphs and search your graph with Java Streams API. It's not a database management system. It's a storage engine. So you have to care for concurrency. This is very important topic and a very important fact. But don't be afraid of concurrency. You can use all concepts that are provided by Java. So there are really various concepts for how to handle concurrency. And even if you use the synchronized approach, then of course it will slow down your application tremendously. But in comparison, keep in mind, you have microsecond query time. In comparison to a database query, it will be still fast. If you want to be much faster, then use other concepts. So this is core Java stuff. You can use whatever Java provides. Of course, there is no tooling for DBAs, so you just have your Java classes. That's it. You don't have to create something like tables with a database tooling. There is no second data model. So there are only your Java classes, only just POJOs, plain Java objects. There are no requirements to your classes. That's a great feature, or that's a great news for Java developers. As I mentioned, there is no SQL support. There are some questions from the audience, mostly. So how can I get access from third-party applications? Well, so your Java developer, Java application is now the center of your application, your business logic, and you should create interfaces to let third-party applications access your database, your in-memory database. So this is a way to do, and you can use GraphQL for that. But you never let third-party applications access your storage data directly. This is very important. And as I mentioned, third-party applications can have access very easy by using GraphQL or REST. This is recommended. So, how does EclipseStore work? Coding. I would say this is all for today in terms of the functional principle. There are some other rules, very simple rules, and mostly this is core Java stuff and object-oriented programming. So please think different. The easiest way is to forget everything you have ever heard about the database server concept. Focus on core Java, on object-oriented programming, and how you would implement it in Java. You can combine and use all Java APIs available in the Java ecosystem. So if you need an index, you can use Lucene, for instance. And we work on a index concept, index API as well. But you can use Lucene, for instance. You can use the vector API. You can use JVector. You can use, as I mentioned, everything that's available in the Java ecosystem. Combine it with EclipseStore persistence. And EclipseStore, this is also very important. EclipseStore just focus on persistence, and so does the persistence job. Everything else is done by core Java or by a Java framework you use. All right. Are there any questions? We can jump in. So Christian have answered a lot of questions already. Should we answer specific?
Yes.
Okay. All right, Christian. Then
to answer everything.
Christian, important question to you. Yeah. Am I in time? Because Christian mostly says I talk too much. So this is the reason why now.
No, it's totally okay.
So. Thank you. So it was a pleasure to be here tonight. So I go now to the EclipseStore party and come back to the Q&A. So enjoy the training and please ask many questions to Christian. Thanks for joining tonight. Bye-bye.
Okay. Thank you, Marcus. Enjoy the party. So, okay, Let's move on. So I have to share my screen again, and as I promised, or Marcus promises all the time, so MicroStream is that fast, and it saves you a huge amount of money. And let me give you an idea how this works. So hopefully you can see my screen now, and you should see the architecture overview of our performance demonstration, just to give you an idea how fast MicroStream is. And what we built so far is we created just a few EC2 instances. One as you see here, as a sender application. And then we have two other EC2 instances. The left side is the MicroStream side, or EclipseStore side, and there is a Micronaut application which provides REST endpoints and has a MicroStream storage behind, and it stores the data directly on the hard disk on that EC2 machine. And it's the same on the right side, but a little bit different, of course. We installed a PostgreSQL server on that EC2. We use the same storage. The storage is also directly on the machine. And there is also a Micronaut application in place with Hibernate and also the same REST endpoints. And both applications are doing the same. They deliver data for the sender application. And in the middle, we have Prometheus and a Grafana board to measure all the CPU usage and the metrics of the systems. And let's have a look to that Grafana board. So we no longer need this. So here we are. This is the Grafana board, and as you can see here, we have 4 different calls that we are able to send to the databases. One is a normal call, and this is the sender application, and you see this is the first call, and here's a short description what is going on the server. So we have a book REST call for 1,800 books with a title, a value, an author, and an ISBN. It's a really straightforward REST call to get the data. And let me just start this easy call, and because it needs a little bit that Prometheus and Grafana gets the values, but yeah, we should directly see what's going on that machines. So we have on the upper left corners, we have the calls per minute. We have down here the CPU of the PostgreSQL database, and on the right side, on the MicroStream side, we have the RAM usages on both sides. And here on the right, we have the response times, average and current response times of both applications. And just to explain that a little bit, so both applications are working with a cache. So also the Hibernate cache is active on the PostgreSQL side. So, and of course, it's the same on MicroStream, because MicroStream is an in-memory database. So that means MicroStream gets the data also directly from the RAM. So, so in my opinion, both applications should work or should perform in the same way. But that's not the truth. And you see that here we are limited to 1,200 requests per minute. So I think that's the result, and we will be able to deliver much more requests per minute. But yeah, this is what it is. But the difference or the comparison to these two is the Hibernate data mapping. And that data mapping needs a lot of performance, and that's the reason why PostgreSQL is that slow compared to MicroStream, because there is, on the MicroStream side, or on the EclipseStore side, there is no more data mapping from SQL data mapping and so on, Hibernate mapping necessary. So That's one reason why MicroStream is that much faster than PostgreSQL. Many other people ask us all the time, okay, what happened if the calls are getting much more complex? Let's give it a try. So let's stop this one, and let's see what happened when we do some REST, some joins. So let's call 1,500 books with title. It's the same, but then we join the stores, addresses, and shop names, and many more on the PostgreSQL. Let's start this. So let's choose the aggregate call. And now we should see that the CPU on both sides are definitely higher than normal. So you see that also MicroStream needs a lot of CPU power for the requests. Let's wait for the data. So I would say the CPU is fully booked on both sides. Oh, come on. Yeah, sometimes it needs a little bit. To check this here. Okay, we are here to 0. Oh, okay, sorry for that. The join call is the right one. So yeah, here we are. And that's the result. So as I said, both CPUs are on the limit, I would say. But you see, we have much more requests or responses per minute on the MicroStream side, 182. And now you see also it's the same on the joining stuff. The more complex the query is, the faster MicroStream is. So and I think that's a good example to see what's going on there. And some of the people ask us, okay, MicroStream uses the RAM, and that's quite clear that MicroStream must be faster than all the others. What about when data is lazy loaded? What about MicroStream needs to get the data directly from the hard disk? This is also a nice example we can do. Let's use lazy books. So that means we don't use caching on the Postgre side, and also we clear we are clearing the RAM all the time on the MicroStream side. So both applications have to load the data or has to load the data directly all the time from the hard disk. And I think it's the same here on the CPU side. Both applications will have an increased amount of CPU usage also on the MicroStream side, because the data has to be loaded all the time, and that needs a lot of CPU. You can see the memory footprint down here. Here you can see the RAM used on both machines. Most of the time, they are quite equal. So this is because PostgreSQL also needs a lot of RAM to stream through the data or to load the data. I think both sides are quite similar on the memory footprint. But as you can see here, it's we are 2 times around faster than the PostgreSQL database. Of course, you can do improvements on both sides. That's for sure. But I think it's a good example to see how fast and powerful MicroStream / EclipseStore is. it's just a small example to show you. If you need to know more about this, we can share the repositories with you. You can do it by yourself or try out this by yourself on your machines. But yeah, MicroStream EclipseStore is really incredibly fast, and I think that's the point on that demonstration. Okay, so performance demonstration. That's it. Any questions so far? Let me just check the chat. There is one. Is the Eclipse serializer a part which come into with Eclipse? It's a separated product. Yes, the Eclipse serializer, and yeah, it's our new invented serialization for MicroStream, and it's different to the Java serialization, I would say. I hope this answers the question. Okay, memory footprint. I hope I answered this, but we can talk about the memory footprint later on. So in some parts, memory footprint is important, especially as MicroStream is an in-memory database. So that's exactly an interesting point to talk about or to discuss. Okay, but I think it's important to have a short look how EclipseStore basically works, and therefore I created. Give me just a second. I have to just to sort a little bit my UI. Okay, so yeah, I created a small Java project here, and no worries, I will share all the projects with you, but this one is just a really small, very basic example. I don't have to share that because there are only a few lines of code in it. And all the others you see, there are Git repositories for that, and I will share the URLs with you when I come to that project. Yeah, Wrap Eclipse 12. We released it today, so it's available now. So you can download it. Okay. Yeah, basic examples. Let me just start on the main class of that project. But first, let's have a look to the POM XML. I think that's interesting. So what dependency we need. So you see, in that case, I use the MicroStream storage embedded dependency 8.1. And there was one question before, how to start with a proof of concept, or so is it important to use MicroStream or use EclipseStore? When EclipseStore is final, both frameworks are the same. But later on, new features will go directly to EclipseStore instead of MicroStream, so it makes more sense to use EclipseStore after it's finalized. So okay, so as I said, we need this dependency, the storage embedded. There are many more. You find all the different modules of MicroStream on the homepage, and I think it's the same on EclipseStore. And let's move on. So we need one object which is called Embedded Storage Manager, and there is no rule how to implement or how to create an embedded storage manager. I've talked with a lot of Spring Boot guys and with many other Micronaut and Helidon and so on. Just to create an embedded storage manager like this and ensure that is the only instance, so it should be a singleton instance of your application. Initialize this and hand over all the specific, let's say all the specific configurations. It's not really a big deal. So it's I think it's how to say, it is, there are no huge differences between a Spring Boot implementation or to use it in a just bare Java project, I would say. And in that case, as I said, I use the embedded storage manager, and this is the most important part of the database itself. this storage manager is the center of the database itself, and it takes care about all the things happened within MicroStream or EclipseStore. We used this short way to initialize this embedded storage. There are many different ways to do that, but this is one way, the shortest one, I would say. We call embedded storage.start, and then we need one root object. And the root object is, as you know, MicroStream or EclipseStore is more a graph database, I would say, and it uses the object graph, the Java object graph, and therefore we need one object on top of that graph. And in my opinion, or in my application here, it's a class named myCompany, just an example class, and I hand over that class to the Eclipse Storage Manager. And the second parameter is where do you want to store the data? And in my example, I store it directly to a folder named data, and this folder is directly created here. We will have a short look to that data folder later on. Let me just delete that data. It's from a previous start, so we don't need that data for now. Okay, that means we have one root object. And we have the storage manager here, and that's it. We call start, and from now on, every time when I access the storage manager, I will get the data which is inside the database. Okay, let's jump into this root object, which is called myCompany. And there was one question I remember a few minutes ago, how to create a multi-tier application. And not sure if I'm right, but there are a lot of people ask us how to create multi-tenant application. And this is one way to do it. Instead of having one class, which is called myCompany or just company, there is the possibility to create one which is called data root. It's just and this data root consists of a collection, and this collection contains many companies, for example. So that means the data structure is totally up to you. So, but in my case, I have one company, and this company contains a lot of customers, and therefore I created a list of customers, and I added one get method to get access to my customers. That's all we need in that company class. And let's have an additional look to the customer itself. It's just a flat customer with a mail, a name, and a first name, a constructor with the fields, and just get and set methods. And that is really important. MicroStream or EclipseStore uses the classes as they are. There are no annotations needed to bind it. It must be being standardized. That's the only point. And then you can use any data structure, or I would say 98% of all Java native data types within MicroStream or EclipseStore. There are some special data types you will not be able to use. You will find these types within our documentation. There are some really special data types cannot be stored, but most of them are possible. So in that case, we use just strings, and that's it. Okay, so we have the storage manager here, we have the company here, that's it. So let's create some new customer objects. So I initialized 2 different customers, and I only have to add these customers to my root object, to my company object. And this is what happened here in line 21, 22, my company, get customers, and I add these 2 customers to the storage. And after that, and this is one part which is really important when you work with EclipseStore. You always have to store the reference holder. That means when you, some people say, okay, that's easy. I just store the root object. I could store the main company object, right? But this is not the object which has changed. in fact, the object which has changed is the list of customers here, because you added some customers to that list, and therefore you changed the list itself. And that means, in that case, you have to store the list and not the company object. And this is one of the biggest mistakes many people made when they used EclipseStore the first time. They store the wrong object. And then they just wondering why the data is not in the database. But this is basically how it works. It's important. You have to store the reference holder or the object which has changed, I would say. And then you are right. Just to control some sysouts here to see what happened at the end. And yeah, let's start the project. So let's say run as Java application. So we see the system out print line from the database. And what we are now doing, so you can see when we now press refresh on the project, we see that the data folder is available again. And we have a short look later on to that data folder to just explain you a little bit how EclipseStore works behind the scenes, and to understand what happened here inside the data folder. But what we should do now is just remove these lines of code. We no longer need this, and just run the application again. And what we should see now is that the data comes directly from the database instead of it is new created. So when we now start the application again, you see the output is the same. So that means the data is stored successfully. And I would say this is a really, really basic example of storing data or using EclipseStore. But I think it helps a little bit to understand what's going on and how to use EclipseStore, basically. Okay, a lot of questions are within the chat. Hopefully, I'm able to ask or to answer them all. Specification or APIs. Oh. Okay, can you give a short overview which software I have to install that the examples run and in which steps this should be installed? Okay, so basically what you need is a normal Java IDE because EclipseStore is a Java storage, I would say, a storage provider. And then I think there is not a special Java project necessary. So you could use a Spring Boot web application, for example. You could use a JavaFX Fat client application. You can use microservice application like Spring Boot, like Helidon or Micronaut or stuff like that. There is no specific type of application to use MicroStream in it. Yeah, that's all you need. And you need the EclipseStore dependency or MicroStream dependency, and then you can use it within any Java project or any Android project on the market. We already used MicroStream a lot of times in many different Android projects on the market. So it works better than SQLite or stuff like that. Okay, I think that I hope that helps a little bit. How will the API change from MicroStream to EclipseStore? I would say not really. The API stays the same. I will show you because I'm able to switch to the new EclipseStore API, and you will see only the imports will change, but the API stays the same, I would say. Another question, is it possible to run 2 or more Java threads with independent EclipseStore instances? Yes, it is. You will be able to initialize a lot of different or a lot of storage managers. If this makes really sense, it's totally up to you, I would say, but basically it's possible. You can have 5 or 6 instances of a storage manager. That's totally up to you. Another question about Java records are fully supported. Use it as you want. So Java records are definitely supported. Date and time types. Let me just think about. I think they are fully supported now. There were some problems on local time or something like that, but we created some special type handlers for local time, local date, and so on. They are supported now, so you can use it. This was a problem on versions 5 or 6, I guess. The date times. There is no serial version ID necessary. That's for sure, because we don't use the normal Java serialization. We use our own invented serialization. And yeah, as Marcus said, this serialization is much more safer than the Java ones, because we don't call any constructors and so on. It's just, yeah, the serialization. I think Florian is able to explain more about the serializer of EclipseStore. It's not my special knowledge. Store the wrong objects, but then I need to know the internals, how the company object is structured. Yes, for sure. Yeah, you have to know how the company object is structured. There are possible ways to create some. I don't want to call it a workaround, but I will come to that later. So you will be able to store a company object as a fully object, but not sure if that makes sense in a lot of cases. For example, so when we use the store method like here, so just say, okay, store, then we call it a lazy store. That means only the object which is part of the, which is hand over here, will be stored. There are some more methods you can use at the end. So there is, for example, one method which is called store all, for example, and this enables you to hand over multiple objects to store. So in that case, that enables you to create, mostly we call it data access objects, and within those data access objects, we take care about of storing the specific values that we want to store, especially in the project. So, but as a developer, you have to know what do you want to store, and this makes really sense. I will explain more about that a little bit later, why it is so important to know what to store, because there is another method, and this is quite funny. There is one method which is called store root. You see that? Which is called store root. And this is also, I would say this is a great method, because it stores the whole database from the beginning, from the root object to the bottom. But yeah, as I said, does it make sense to call this store root every time? Yeah, in some parts it makes sense, but not every time. So I would say. Okay, but I will explain that a little bit later. Okay, a lot of questions. Yes, no, it's not the same. There is, let me just say that. Store, and then let's say my company. This is what you said, right? This is not the same as store manager dot store root. That's not the same, because as I said, this store method, we call it lazy store, and only the object is stored which is part of which is hand over, and not all the objects above. So that means it stores only the object itself, but the store root stores the whole graph again. And I think that's a different. So, and there is another method. Let's just show it here. Create an eager storer. So you will be able to create an eager storer, and now when we use this, when we use that eager storer, we will be able to, when we now say eager storer, and now we say my company, then we have the same like the store root. And that's the same in that case, because it stores everything below that object, everything which comes after that, all the sub objects and stuff like that, because it's the eager storer. And this is also part of the transactions we talk about later, because when we call store, the object is not stored directly. You have to call eager storer dot commit. But this is another topic, and this works like a transaction, I would say. But I will come to that later. Okay. Hope that answers that questions a little bit. Can you have 2 or more embedded storage instances within the same VM? Yes, it's possible. I already explained that. You mentioned a good practice to have when considering multi-tenant application. Could you please recall your advice? Okay, so especially when we create multi-tenant application, then we let me just add the store. I think that's right. Yes. So let's say we have multiple companies, and every company is a separated tenant, I would say, and then it makes sense to have not a single company on top as a root. Instead of that, you would have one, I would say, one object which is called data root, for example, and it consists of a list of companies, and each company is a separated root entity, I would say, because they are not able to interact each other. But there is also a possibility to have multiple, as I said, multiple storage manager, and this could also help to create multi-tenant applications. Yeah, maybe that helps a little bit. Okay. Yes. Let's have a look to the data folder and give you an idea how the storage basically works behind the scenes. So because a lot of people think, okay, data are stored within a graph or something like that, but that is not really the case. The only graph we have is our object graph within Java. That's for sure. That's our object graph. That's our basic object structure. And for every object we have in our project, we have an entrance within a persistence type dictionary. So as you can see here, every specific Java data type is part of that persistence type dictionary. And as you can see here, there is one file within the data folder, which is called persistence type dictionary. And the point is that every object has its own object ID. You can see that here. For example, the float has the object ID 6 or 7 is a long, and double is 8, and so on. And when we scroll down, we see that our customer should also have a specific object ID in that. You see that? Here we have the customer. And the customer has the object ID, what is that? 1 million, something like 174. This is the object ID, the object type ID, I would say. And as you see, every Java object within our persistence has its own object ID. Okay, that's the first point. We have an object ID. The second point is when we have a look to the channel file, and this is the file which contains the data. This is your data. This is the binary file. which contains the data. And so the point is, every transaction on the database adds data to that file. So, and that's the special thing on EclipseStore. There is no deletion of data, or there is no, when you call it delete, for example, we do not remove files from the storage. And it's the same on if you update an entity. We do not update the entity within the storage. So what we do is we add a new object at the end of the binary file. So let's say we change one specific customer object 5 or 6 times, and that adds the same object 6 times at the end of the binary file in different versions. So that's kind of like a versioning which is going on in the background. And there is one housekeeping process, and that housekeeping process goes through the file and clean the duplicate entries from time to time. And that's how it basically works. And there is a second point on that file. We have an object type ID, and we have an object ID itself to identify the object for the storage. This is not a readable value for you, but it's for the storage internally. There is an object type ID and an object ID, and you will not be able to read this binary file. It's basically not possible to read this binary file, because you have to know which object type is it, and with the object type you can go to the persisted type dictionary, and you will see, okay, it's a data type which consists of a string and another string and another string, for example. You see that here, and then you know the length of the binary. So that means to read the values from the channel file, you have to know the type IDs from the persisted type dictionary, because you need to know the length of the binary strings that are part of that file. I would say it's quite complicated to explain, but I think it's important to understand that we don't store a graph at the end. We store just binary files, and every action on the database adds a specific part at the end of the storage, and then the storage will be saved, and the housekeeping process cleans up all that stuff in the background. I think that's basically how it works. I will explain that a little bit more in detail on the advanced training, but for now I think it's totally what you need to know. That's great. Yeah, that's really great. Okay, so let me just check if I answered all the questions. Can you show the Java class where existing data from previous run is loaded? Static? It's okay. It's it's let me just here we are. So the point is that there is no class which knows where the data is. It's only an embedded storage manager, and he knows where to find the data. And then in my case, it's the data folder here, and it tries when on startup, the storage manager tries to read the persistent type dictionary and analyzes the storage on startup, and based on that, we are able to access the data. You see the storage manager, and we use the storage manager. Okay, and you see here, my company is part of the storage manager, and based on that, we are able to deliver the values from my company. That's how it basically works. So the storage manager knows whenever we access to my company that then he and my company is a root object or is part of the root object, and then you will get the data. The point, I think that this is nothing really special which is ongoing here, because the data is in memory. As I explained, MicroStream or EclipseStore is an in-memory database. That means on startup, the data is loaded directly to my company object, and because of that, we are able to access the data. That's also the point why we are able to search the data within the RAM with the Streams API. So the data has to be in the RAM, and that's how it basically works. And that this is also an important to know that your root object is your database, and all the data is within your collections, and you have these data directly available in your application in the RAM. And this is how in-memory works, basically, and should work, basically. Yeah, I guess most of the questions are answered, I would say. Maybe Marcus can get on the last question. I'm not really able to answer this. But yeah, let's move on within the training. So it's important to talk a little bit about a proper data model, because some of you might say, oh, okay, how boring it is to talk about data model. Everyone knows how to create a proper data model. But yeah, the reality, I would say, is different. And I've talked with a lot of developers, and they ask all the time the same questions, because the point is you always work with relational databases, and most of the time you use Hibernate, of course, and then you are tied to a specific data model which can be handled by Hibernate, for example, and which fits best to the relational database. And but with MicroStream, it is really different, because the Java world is so much more powerful than a Hibernate data model, and therefore, yeah, we need to talk a little bit about a proper data model. And we don't need this, but let's start on an example. So let's imagine we are a book selling company with multiple bookstores, and we are selling thousands of books a day to our customers. What most important nodes or tables do we need, and how the relations would look like? Okay, that's easy, right? So book selling company, so that means, okay, we need books, of course. We need company informations, maybe somewhere. We need stores, of course. Orders would be important. Orders to have would be important, and then maybe authors could be, and customers, of course, we have, and some of that. So that means, okay, we need companies, books, authors, stores, customers, addresses, and orders. And yeah, maybe employees, but they are not that important for now. And we all knew this is the structure on a relational database, right? So we have a lot of tables. Each table sounds like or have the same name like the entity on the Java side. So let's say we have a book entity, and therefore we have a books table on the relational database. And each of that books, or each of the authors and stores and so on, has its own primary key and foreign key, right? So this is how a relational database mostly works. Some constraints within, but not that important. On the Java side, we see the data structure looks like this. So on the Java side, we have, let's move back. Yeah, we have an object model, which looks like this. So, and you see the data structure is totally different, but yeah. And now let's see how we would create a data model on the MicroStream side. And this is also the answer to the questions of many people, how to convert a relational database model, or how to migrate from a relational database to MicroStream. And this is also a great answer to that. Let's have a look. Let's start on a specific object within that structure. And as I said, we need books. Yeah, this is our first important entity we want to create. That means let's do so. Let's create a new class which is called book. And a book consists of a private string name of the book. So there is another thing. We have private string ISBN of the book, and private, yeah, what else do we have? Let's call it local date release. Each book has a release. So we need get and set methods, but they are not that important for now. So it's just the book itself. The first question, what about primary keys and foreign keys? Do we need that within MicroStream? The basic answer is no, we don't need that. We don't need a primary key, and we also don't need a foreign key. But what we need is an identifier, of course. We need a unique identifier of the object. And I think that's quite, yeah, that's really straightforward. In that case of a book, the ISBN could be the identifier, for example. That's a good example. But what if we have, let's say, if we have an order here, for example? So do we have an identifier within an order? Yeah, maybe the order ID or stuff like that. But it's not that straightforward than within a book with an ISBN. And for that, it might help to have things like that. We usually do, we create a UUID, and then we say UUID dot. This could be a solution that helps you to identify an object, because this is not a business object. This is just an object to identify, to do equals and stuff like that, and you have to override the equals method and so on. But this could help to create a proper identifier for your objects. But you will not need a primary key or a foreign key, because the object graph itself are the references to the whole object. But a better question is, now we have one book. How can we store a book like this? So what do we need? So this is just the book entity. We need another class which contains a list of books, right? So and you see, when we switch back to the presentation, MicroStream is a combination from this side and this side. At the one side, we have a book object here. So here is it. So, but we need a list of books. This is the kind of like the table on the relational database side. And here we have the books. And therefore, we have the book entity here, and we need another class. And let me just create a class named, yeah, let's call it data root. And here we have a list of book. Let's call it books. And let's choose an array list. Should not forget the private. Okay, that's it. Yeah, is that okay for you? So we create a book, and then we need a list of books somewhere within our application. Okay, but when we have a short look, then we see we are a book selling company with multiple bookstores. That means each store has its own books. And then we have to add stores. So that means we have to change a little bit. That means we need another object, which is called store. And again, we need a list of stores within our root. So that means, let's say store, stores, that's it. And now we are able to move books to our stores. So that means let's move on to the store and let's hang these books to the store. So, and now you see the difference to a relational database. We don't have a list, a whole list which contains all the books of the application anymore. So there is not only one list of books, there are multi lists of books in each store, and that is really different because it creates a totally different data structure. And in that special case, you see that it's a combination of this, but on the other hand, totally different to this, because there is not only, as I said, one list of books, there are multiple lists of books for each. In each store is one list of books, and there are many more possibilities to create data structure. But next question, what about our company? So we have one company, you remember, we are a book selling company. So, and what I did here is I created a class which is named data root. Does this make sense? This is I would call it a non-business object. Nobody knows what data root is, but in our case, we will be able to rename that class, and we could say, okay, let's change the name and let's call it rename. Let's call it company, because it's a company business object, and our company consists of one company, and this company could have private string name, and so on, many different possibilities. So that means we have our company, we have with some primitives in, and then we have a list of stores and so on. And there is a next question. What about the authors? So you would say, okay, each book has an author, and you are right. So let's do so. Let's create a new class, which is called author. And as always, let's create private string name, or let's call it last name, whatever. Oh, come on. Stop, copy paste. So, okay, private string last name and name. And now we have to add this author class to a book. And I would say it's a single value. Let's call it author. Okay, nothing special. There is one question, should not also an amount of each book in the stock of the store? Yes, you are right. That could be the case, but not in my example. So, but yeah, you're right. Makes sense to have that. But I think especially for that examples, that is not that really important. I just want to point out some special things of data structure you have to care. Okay, and in that specific case, the author, we have to think about, okay, what happened when we delete a book? So let's say we have 3 books from Stephen King within our stock, and what happened when we delete the last book of Stephen King? What happened then? I would say we lost the author Stephen King, right? So because there is no Stephen King anymore, there is no book of Stephen King anymore in our stock. That means when we now try to fill a combo box to choose an author for a new book, for example, let's say we get new books from Stephen King, then there is no Stephen King in that combo box. And this is also one interesting thing we have to deal with. So how to ensure that we have a list of authors within our application. Okay, let's make it like this. Let's say that should be a global list of authors, because it's a company thing, I would say. Let's add a list of, oh, that's the wrong class, I guess. So this one is the right one. So let's add another list of authors to the company. That's okay, right? So Some of you might say, oh, okay, I see, but this seems to be duplicate data within our application. What do you mean? Is that, what do you think? Is that, yeah, it is data root. It is data root because we changed the name of data root to company because we want to have a business object as a root object. And that's a different, it was the data root before. Okay, so company, and we add a list of authors. Oh, sorry, I missed this. Okay. Come on. Okay, so let's add an S. Now it's right. Oh, this one, I forgot this. Okay, that makes sense, right? So what do you think? Do we have duplicate data here? Of course, not really, we don't. So because authors are just a reference to one object, and the data is not duplicated. Of course, we have a duplicated reference, that's right, but the data itself stays, yeah, as one author in the RAM, so no duplicate data. But of course, you have to take care about a second list which contains the authors. But then I expect books also there. Yeah, I would agree. When we need a list of books on the market, yeah, then you are right. So when we want to have a list of all books in the world, it makes sense to have a list here. But especially for books in a stock of a store or stuff like that, I think it's okay if we do that in this way. Okay. Some people ask for an index. So I think that's this is a really good example. So let's say we want to have a list of all books on the market. This is a great example. So let me just jump back to our store. Let me just copy this. That helps me a lot. That is great. So we have a list of books, and now we have a problem. So let's imagine there are millions of books on the market. Or even more, so doesn't matter. When we want to find a specific one, so we have to stream through the whole collection of books, right? And this is, sometimes it's not the best way to do this. And the answer is, let's use a different data type for storing books. You have an idea what could be more efficient than a list of books? Someone of you have yeah, and hash map. That's great. Yeah, private. Let's use a hash map. And let's say a string, and we have a list, or let's say we could do it in this way. Book, come on, equals new, just a second. Books per ISBN. Let's call it like this. Let's say hash map here, and now so this is the way we want to have it. So, okay, a map with a string. This string stands for an ISBN, and the book object itself. Yeah, that could be one solution to have that. What else we could do? That could be another solution, maybe more efficient than we have the ISBN as an index, right? So that could help a little bit. But there is another possibility. We could do things like that, to say string, and now we only use the very first letters of the ISBN, and then we have a list a list of books. Let's do it this way. That could also be interesting. Then we have the first 4 letters of an ISBN as an index, and we don't have to stream all the books when we're searching for a specific title or stuff like that. Then we will be able to search for the ISBN first, and then and of course that string we can have multiple collections like this in very different ways. And as I said, of course, the references are duplicated, but the object itself is just a reference. So that structure here does not duplicate the data at all. So it just duplicates the references. That's right. And there is another thing I want to add. We talk about that later on, about lazy loading. Marcus mentioned it, lazy loading. It's not necessary to have all the data all the time in memory. You will be able to decide which data stays on the hard disk. And therefore, there is, I will give you one example, but lazy loading is a topic for the advanced training. But just for you to know how to use lazy loading, it could look like this. We use the lazy, this is a lazy wrapper class, which is provided by EclipseStore, and everything within the lazy wrapper class stays on the hard disk. That means these books are not loaded on startup, and that helps you a lot to handle a huge amount of data. And yeah, it depends a little bit on how to use the lazy loading stuff, but there is more in detail on the advanced training. But this is the basic way how to use the lazy for lazy data types, or to ensure that the data is not loaded to the RAM. Okay, I noted another question. It's all about, people ask me, okay, how do I know when to use lazy and or what data can stay on the hard disk? The problem is, and this is also a discussion, how much memory do we need for microstream? Basically, I would say you need the data on the application server, or the core data. You will need the data on the application server anyway, because with an increasing amount of concurrent user, they call for books, or they read books, search for books, and so on. You need the books within a cache on the application server anyway. So most of the time, it's nearly the same to the on the application server side. But you should not forget, when you order, let's say, a PostgreSQL database, and you want to handle gigabytes of data for it, or terabytes of data, for example, then you will need a PostgreSQL server which has, let's say, 128 gigabytes of RAM, for example. It's quite normal to have a relational database like this, and then you have to summarize all the different parts of your architecture. You have the database itself, then you have maybe an Elasticsearch server in between, then you have the application server itself. And now when you summarize all the stuff, and this is the part you have to compare to microstream, or what you need for microstream or for EclipseStore. And that makes things different to calculate, because many people say, oh, okay, EclipseStore is in memory, I need a lot of RAM on my application server side. Yeah, maybe you need it, but you need it anyway on your different architecture layer, on Elasticsearch, and so on and so on. Okay, that's just a small information. As I said, there are more detailed information to the lazy, and I think that's to summarize that. Many people ask, what about data structure, and you have to consider a lot of things. Where are all my lists? How to store the objects? What happened if I delete an object? What about primary keys and foreign keys? We talked about that. Is there something else than lists and set? Yes, of course, you have hash sets and maps and stuff like that. How about bidirectionals? That's also an interesting point. Bidirectionals, does it make sense to have, for example, a list of books within the author class? Could also be possible to have that. Let's say, where do we have the book author? Here we have. So this could also be possible to have books within your author, and maybe that's a better way to indexing books than, for example, to have a map like this. You see, a data structure there are so many different solutions to create a data structure. And I would basically say it depends on your needs of the application. And I think that's most important. In the past, we all the time created application or data structure that fits best to the database. But now with EclipseStore, we are able to create a data structure which fits best to the application itself and to the application needs. And I think that's a big point, I would say. Okay, is the recursive storage problematic? I don't think so, because MicroStream or EclipseStore can handle references. Yeah, and I think that isn't not really a problem. Of course, you need to take care about, or the developers have to take care about all the relation and how they interact to each other. But yeah, you have to deal with it. But I think it's the same on Hibernate. Yeah, when you have bidirectional relations within Hibernate, you also have to take care to both sides. So when you, for example, when you remove a book from an author, on the other side, you have to remove the book itself or the author from the book. So it's totally the same also on the Hibernate entities. Okay, this is all I want to talk to the data model, or to create a proper data model. And you see, it's difficult to say do it like this or do it like this. But on the other hand, especially for the migration, when you migrate from one data structure to another, I would say that is quite easy. Just you have your application already in place with access to the relational database, then create your storage manager and just start up your application and run some migration code that copies all the entities which are already in place because of Hibernate, and just copy all the objects to the different MicroStream storage. And that's it. That could be a good migration from one storage to another. Okay, now I'm done for the data structure. Some questions to that. Let me just check if there are some questions which are not answered so far. An optional SID in MicroStream. Optional. That's a good question. I'm just asking myself why you want to have that. Not sure if I get it right. An optional? Of course, I knew what. Yeah. Okay. Okay. I've never seen that before. On the first few, I would not recommend that, but maybe on the second one. So, I think the important point is the optional data type supported by MicroStream or EclipseStore? And I would say yes. There is a list of supported. Let me just double check this. Just a second. Question one. Specialized type handlers. So here we have the documentation, and here you see all the different type handlers or special type handlers that are supported by EclipseStore and MicroStream. Here are a list of supported classes. Maybe that helps you a little bit. Just try it out if the optional is working. I'm not really sure if this makes sense to create a UUID on. So I think it's a string at the end. It's just a string. It's only created on. Yeah. What is it? Books. It was books, right? So this one here. Yeah, but the question is to have an optional here. But yeah, I've never done this before. So okay, so let's move on. Time is running out. I want to create one hands-on project with you. So if you want, you can do this together with me. So let me just share you the link to the project itself, which is called MicroStream car exercise. And there are two branches, and one is the start exercise here branch. So let me just share the link with you. So here it is. This is the link to the project. And don't be afraid, it's a Micronaut project. And just to, I try to prevent or not to use any UI stuff. And therefore, I decided to use a Micronaut project so that enables me to create some REST endpoints at the end in an easy way. Okay, let me just move to the car exercise. Here it is. I'm already in the master, so let's move to the different branch. As I said, there is one branch which is called start exercise here. Check this out as a new local branch. So we do not need the basic project anymore. So let's clean this up a little bit. Okay, so what you really need for that project is any Java IDE on the market, I would say. Git, of course, to check the project out. And then you should have the project here. And the start exercise branch contains only a few predefined classes. So as I said, there is one which is called application. This is the main startup class of Micronaut. Then we have one DB class, but this DB class should be empty. So we are able to create a new storage, embedded storage. Come on, new embedded. What is it called? Storage provider. So okay. Then we have some predefined domain classes. One is the company. This company, as I said, is our root object. Later on, then we have a car object and a brand object, and we have two controller classes, which enables us to create specific controllers or to get the data. The only thing you have to do is, which is really important, you have to enable the annotation processing within your IDE. So that means especially on RapidClips or on Eclipse, and I think it's the same on IntelliJ and so on. Just search for annotation processing. It's somewhere within the Maven stuff, and then you can set it to experimental or to automatically. I think both will do the same, but the default is do not, and this will not work. So you have to enable this. Yes, yes, and then you will be able to start the project. Yeah, to enable that annotation processing, you have to do something within IntelliJ. Yes. Just search within your preferences. Give me just a second to Google that. Annotation processing. So, yeah. There is a link which describes how to enable it. Yeah, you will find it in build, execution, and deployment, compiler, and then annotation processors. And then you can set the hook to enable annotation processing. So let me just double check to start. In my case, I can start, you just move to the application class, and then you can say run as Java application. And this should look like this. Then you will get the message within your console to see startup completed and the time. And you will be able to access the application on HTTP localhost 8080. And the result should look like this. Page not found, that's okay. Because there are no endpoints available for now. So this result should be okay. Yeah, thank you, Frank, for the link. Let me just copy this. That sounds interesting. Have you created this project? MicroStart is here, right? Okay. Just okay. So let me just summarize this a little bit. Check out the Git repository I shared with you. I could do this again. So our exercise is that this is the link again. Just check out the project on the create starter or start exercise here branch. Enable or activate the annotation processing within your IDE. And yeah, as I said, you can start the application. Go to your application class, right click, run as Java application. You should see the started Micronaut application. Yeah, it's already in use, but yeah, should look like this. Okay. There is one I have to add. I will not use the special Micronaut integration here because it's the fundamentals training, and for me it's more important to share the normal EclipseStore experience, I would say, and therefore I just use the normal initialization of EclipseStore, and I'm pretty sure that helps you more than to see how to use this specific Micronaut integration. Okay, are you ready to go? So then let's move on. Let me just have a look to. Okay. Yeah, okay, we are ready to go. So what we need at first is our embedded storage manager. So, and therefore we say, okay, public, oh, that's not what I want. So public, oh, public static embedded storage manager. And do not forget, the dependency is already in place. So that's why we are able to create the storage manager. If you want to know what version is in it, just check out the POM XML and you see the version 8 is already included. Oh, I see there is one mistake. We should also update this to version 8, but that's not that important for now. Okay. Let's jump back. So let's create an embedded storage manager and let's call it storage manager. So we need this one. And then we need one instance of our root object. And for that, I also call public final static. Yeah, as I said, there are many, many different possibilities to initialize all that stuff with records and all that other fancy stuff. It's totally up to you to do that, but in my opinion, I want to keep things easy to use it, and therefore I just use the Java basic stuff, I would say. And to initialize all the two classes here or the two objects here, I create a static block. So, and that means whenever I access the embedded storage manager, it will be initialized, and yeah, if it's available, so it's okay. So how to initialize a storage manager? And this, I would say, this is that's important. I think the way I initialized the storage manager in that example project is the most important way. It works best for me on all the other projects I use. So I call it embedded storage manager, and then we use the builder pattern. Oh, sorry, the embedded storage configuration. And then I say builder. And that builder pattern enables me to define every configuration. And the first I want to configure is the set channel count. This is also what we talk about in an advanced training. A channel count defines the amount of folders on your hard disk. So that means when we define two channels, we are able to access the hard disk with two threads. With two threads in that case, we could do this in 4 and 8 and so on. And you have to find a good value for you, or a good configuration for your storage. When you have a lot of lazy stuff and you have to load a lot of lazy references from your hard disk, it makes sense to have more channels. But the more channels you have, the more the more split it up is your data, and that means it takes a little bit to collect all the things together. So you have to find the right balance between loading fast with multiple threading and to think. I think in most of the time, something between 1 and 4 it's totally enough for it's a good configuration, I would say. There is one question: is an atomic long or index and a re-entered write log synchronized sufficient? Of course it is. I would, so especially the re-entrant write log is one I would recommend to handle concurrent access to the data model. Yeah, you can use every single concurrent solution within Java in combination with EclipseStore. It's totally up to you. Okay, channel count. So then we have to set the storage directory. So let's say storage directory, and we do it in the same way like before. We call it data. And then we have to create the embedded storage foundation. That's important. It's always the same. So the first you do the configuration. Then based on that configuration, you create the embedded storage foundation. Based on that foundation, you create the embedded storage manager. The manager gets the root object, and at the end you have to call start. That's important. You should not forget to add the start method at the end. It happens to me multiple times, and I always think, oh my god, why MicroStream is not storing the data? So that means I forgot the start method at the end. Yes, it's allowed to use multiple channels in the free version. Yes. And it's all we have to do. So this is everything we have to do to set up our database. That's it. Let's have a short look to the company itself to just ensure that everything is in place on our data structure. So we have a company. The name is, I don't know, but this company contains a list of brands and a list of cars. And that's all we need. Just a small example. And let's move on. Let's jump into the car. Car consists of one model. So it's the name of, or it's a model, or the model of the car. Then we have the brand, if it is a BMW or a Mercedes or Audi or something like that. Okay, so that means this is already in place. We don't have to do something within here. So DB class, the domain classes are in place. And let's have a short look to the controller classes. And let's start on, let's say, let's start on the brands controller. So the class itself is prepared like this. So we have two methods we should fill. The first one is the get brands method. And this is really straightforward. So how to get access to our brands. The first class we navigate is always the DB class. We say db.storagemanager.getRoot. That brings us to our company class. And then we could say, okay, we forgot something, right? So let me just double check. Okay. I forgot to add the get and set methods here. So you should add additionally two get methods for the storage manager and for the root object, and then we are able to use this directly. So we can say db get root, and then we could say get brands, and that's it. I think there should be, let me just double check. That should also work on db.storagemanager.root. I think that I have to cast the object in that case, but okay. I think it's better to do it like this. So just add additional get and set methods to the DB class, or especially the get methods are important. We don't need those setters. And let's return the brands. So to insert a brand, we use stream filter. So I just copy paste a few lines of code from another branch, and you could also do this. Or just let me type this. That's also okay. So I want to shorten that a little bit. So yeah, let's do it like this. So that means I shortened that a little bit. So when you have a look to the master branch, you will see that within the master branch there is a check if a brand is already in place and stuff like that. We don't need that really. In my case, it's much more important just to create a brand. And there is also a thing what you should never do, to use your brand domain class as a data transfer object. I do this way because it makes the code a little bit easier or more understandable for the training. So and therefore I use the brand directly as a transfer object. But normally it should be a special data transfer object for loading the data. Okay, that's it for my brand controller. So I can share this code also with you. So just copy the code from the chat. So let's move on to the car controller. There are some more methods in it. Let's start with the list cars. With the list cars, it's the same like on the brand. So let's call DB for our database class. Get root.getCars. That's it. This should return all the cars. Now we skip the next one, and so now we move on to the clear cars. Let's skip these two methods here. Let's talk about how to clear the cars. That could be interesting for you, because this is how to delete data within EclipseStore. So let's say db.root.getCars. And it's just a clear like this. And there was a question few hours ago, I would say, if it is dangerous or it's easy to delete stuff. As long as you provide a method to delete something, you will be able to delete something. I don't think it's more dangerous with MicroStream to delete data than in other databases, but yeah. Basically, you are right in a specific way, because in most of the databases you have all the database constraints that prevents you from deleting data, and that is a little bit different in MicroStream. In that case, you are right. Yeah. Okay, so db root get cars clear, and the important thing is you have to store this. You have to say db.store. .store, and now you remember what I told you at the beginning of the training, what object has to be stored here. And in our case, we changed the collection of cars, and therefore we have to store the collection of cars. And let me just check Yeah, okay, the response is missing. So let's say return HTTP response, cars cleared successfully. Yeah, DB. Okay, yeah, that's right. I see. Because I made it public. That was the basic idea. Because okay. Yeah, let's do it like this. Let's keep it public and not really the right way to do it, but it works. So we should be able to get root this way. Yeah, could be final, of course. It could be final. So you will never change this. It makes sense to have that final. Yeah. Okay, car controller. Let's talk about the last one, the insert, and I would say it's barely the same with and I will copy paste this from the other branch, because we have to create a brand and stuff like that. We have to find the right brand. I will also share this with you. I copy paste this to the chat, so you can also take this and copy paste that directly. So let's have a short look to the code. So we search for the right brand. And this is also a reason why I want to skip this, because I want to talk about streams a little bit later on. So we didn't talk about streams, and some of you might not be aware of streams. So that's why I skipped this a little bit. But yeah, we search for the right brand in that case, and then we get back an optional brand. So that means it's there or not. But if it's there, if it's present, then we get the brand out of the optional object. And then we create a new car object, set the brand, set the model, and this is the model out of the data transfer object. And we say, okay, give me the cars collection and add a car. And this is what I have to do. So store db root get cars. Of course, I have to return the car. Yeah, just easy stuff, I would say. Okay, so let's try it out. Hopefully I have the right DTO classes, the right JSON objects. Give me just a second. It's part of my Postman, so I can also share this with you. Yes, I'm a human. And yeah, it worked great. Okay, so let me just find the right application. Car exercise. Okay, here we have the order. And okay, so yeah, that might be a little bit complicated for you, but as long as you have Postman in place, you will be able to create a call for that. So what we have to do is we have to start the application first. So that means let's jump back to the application class and say run as Java application. That's the first step. Then the application itself is up and ready, and we have to check the path. So that means in our car controller class or brand controller class, I would say it's /brands, and then we call /insert. And that insert enables us to hand over a JSON object, which you can see here. And yeah, let's try to send this. And you see on the first access to the static DB class, it creates the new microstream instance. This is the initialization of microstream itself, and it automatically stores the Mercedes brand. So let's add another one, BMW, for example, and send it. That's it. Let's do an audio, of course. Okay, that's it. So we added 3 types of brands. And with another method, it's a get method, which is called all brands. I can send that request, and the result. Brands. Okay, it's a different port here. I see. Yeah, you see, this is the result. Here are my brands of the database. I added Mercedes, BMW, and Audi, and these are the brands. And it's the same. Let me just share this with you. So maybe insert a brand. That is the JSON file for inserting a brand. Just as an example for you, you don't have to type this. And it's the same. It's the same body for the body for a car. Looks like this. So this is one example of the body of for adding a car. And let's do it. So let's insert a car. Let's call it, yeah, it's a model 330 with a brand BMW. And let's say insert. And that's it. When we now call a list of cars, we just double check which is the cars. Yeah, that should work like this. All cars. Here it is. So we see the BMW. The tool I used it's called Postman, and it enables me to add some data or to call the REST endpoints of the application itself for you, or if you don't have that tool. So there are many other tools which can be used to call the REST endpoints, but I think you should be able to call the easy endpoints, especially list cars, for example, and you can do this within your browser. So that means when you open the browser and you call localhost 8080/cars, for example, you will get a result looks like this. In my case, I already added a car. It's the model 330 I added before. But in your case, you should get an empty result if you're not able to use the Postman. So I hope that helps a little bit. I think there is also a possibility to use the browser, a browser plugin also to add a specific body. But I think, yeah, that helps a little bit to understand how microstream or EclipseStore works. And I also would say it's more important to understand the basics behind EclipseStore and how it basically works instead of understanding all the Micronaut stuff around that example. But you have the access or you have access to the GitHub repository. Feel free to check it out and have a look on all the other stuff in my repository to see how it basically works and check it out or use it with Postman and so on. Okay. Yeah, there are a lot of tools on the market. So any questions so far from your side? So we talked about how to initialize. We talked about yeah, the data structure and what's going on behind the scenes. We talked about how to access the data. So I would say most of the CRUD functionality, we already talked about this, how to clear data, how to add data, what especially what object should be stored. So it's always the same. You should store the object which has changed. That's important. And yeah, in the next few minutes, I want to go through the Streams API. So just a question, who of you already used the Streams API? Just raise your hands, just to have an idea how many of you use the Streams API. I would say the most, I guess, but okay. Okay, as I thought, yeah, a lot of you guys used it. So, but anyway, I prepared just a small presentation, and this is just to talk about the most important functionalities of the Java 8 Streams API and what it is and basically how it works and so on, because this is also an important part of Java, and especially for EclipseStore, because that enables us to create stuff that is similar to SQL. It's a query language for Java collections, and that helps a lot to find the data within MicroStream or EclipseStore. Yeah, that is exactly what we are going to do. So let's have a look to stream through hash maps and stuff like that. Okay, what is a stream basically? It's per definition, it's an aggregate operation, computes a single value from a collection of values. That's one point of a stream. Another, or a result could be a primitive value, so like a long or an integer value to count something or to get the max value out or stuff like that. A single object like a customer to find a specific one, to say, okay, find a customer with the customer ID 5, for example. A list of customers, that's also possible, to search within a collection for multiple customers with the same value, for example. Void could be a type of a result, and we could have an optional. So, and mostly we have an optional customer together, or especially when we search for one specific one. For example, when we search for a customer with the ID 5, then we will get an optional back, and there could be a value in it or not. Again, a stream is a sequence of data elements supporting sequential and parallel aggregate operation. That's also interesting because it enables us to stream through data in parallel or in a sequential way. And sometimes it's quite dangerous to use the parallel streaming, but it increases the performance a lot, of course. Let's talk about later in detail to that point. And in easy words, it's a query language for Java collections and a modern way to process collections. And I prepared some examples for you. And yeah, you might laugh a little bit, but even me, I created this presentation, but I have to open this presentation a lot when I creating streams because that helps so much. Yeah, but sometimes you forgot a lot and stuff like that. Okay, let's talk about processing data. So just to go through a list of, and that will also help you. For example, the new class, an instream. It's an alternative for the for loop, I would say. There are possibility to create something like instream of 1, 2, 3, 4, 5, 6, 7, 8, or 9, and then say for each, and then you can the Y stands for the number you process, and you can sys out the number, or you could say an instream with a range. So, and in that specific case, I guess the 5 and 10 is included, but not really sure about that. I mean, there is another one which is called range included or excluded. Yeah, but I think the base is the same, and you can print out the Y at the end. Array stream, that could also be quite helpful, especially as an alternative for a while loop. So we have an array with the numbers in it, and then you could use stuff like streams of, and then you can add the array, and then you can say for each. That could also a helpful thing to have. And of course, there is, I would say, the thing which is used most of that, the collection stream. You can say db.root, give me the books, and then you for each through all the books. And yeah, to be honest, it's, yeah, I think the last usage of a for or while loop is, yeah, years ago. Most of the time I use array streams and stuff like that. Sometimes you need while loops for some, yeah, result set reading or socket programming stuff and stuff like that. But yeah, it's really special. Okay, the different collectors. So what collectors means is what you get back from a stream itself. So that means in that case, we talking the first time about to filter something. So when we say, okay, give me some specific books of a collections, you will be able to say, okay, give me the list, give me that as a list, for example. And therefore, there are some collectors. There is a collector for to array, to list, to set, or to string join. This is quite interesting and sometimes really helpful to have a string join, and you can add a character for joining those strings. And this enables you to say, okay, give me the lists or give me the books I search for as a list or as a set, or as I said, as a string join with some comma separated values in that case. Could be quite helpful. And there is another thing. This is to collect multiple objects, and then is one or for collecting single objects. This is the find any or find first. And with find any and find first, you always will get an optional value. And this is not what you should do, because the .get will throw an exception if the result is empty. You should always check if the optional is present, and then you can call the get method of the optional. But yeah, this is just as an example. So that means the collectors are always at the end of a stream. So you say, okay, this is the collection, what you want to stream. Then you say stream it, and then you can say, give me that collection as a list or a set. This is also quite funny. Some people always ask how to remove duplicate entries of a list, for example. This could be a solution to say, okay, let's stream through the list and let's move the objects to a set. And then automatically you will remove all duplicate entries of a list based on the equals method, of course. Okay, so the collectors always stays at the end. It's the same on find any and find first. So that means the collection itself, then you say stream, and then you say, okay, what should happen at the end and how to collect the data. Collectors. Next step is the filters itself. That's also quite interesting. So let's say we say, okay, DB root get books. This is the collection itself. Then we say stream, and then there is a keyword which is called filter. And within that filter method, you can add any predicate, I would say. Let's say b.getName starts with an A, for example, and or some equals, stuff like that. But I think more important is that part here, some predicates. Since I know that are existing, I use them quite often because it makes code so much more readable, in my opinion. So that means you define the predicate itself in a specific line. So let's say, okay, there is a name predicate to find the right book based on the name. Then we have an ISBN predicate, and then we are able to chain both predicates in a third one. And then we can say name and ISBN predicate, and we can chain it in this way: name predicate and ISBN predicate. And this enables me then to say, okay, yeah, let's create the stream, and then we say filter, and then I have to only hand over this chain predicate, I would say, and that makes things much more readable than. So there is one question. I come to that question later. Or let's answer that question now. So what about paging? Or let's say I have 1 million objects and don't want to get them all at one time. What do you think? Is that a problem? Especially with EclipseStore? So when we depends on the size, yes, definitely you are right, but I would say, in my opinion, that could be a problem, especially with a relational database. It will be a problem because a relational database is always it's always a database server, which is not part of my application server itself. But especially with EclipseStore, the data is in the RAM anyway, so it makes no difference if there is a result with 1 million or 2 or 3 millions. The result stays is within the RAM anyway. So I don't care about getting 1 million objects. But to be honest, I think it makes sense to have mechanisms in place for paging and stuff like that, of course. Yeah, but we have to talk about this in a later advanced training. Yeah, that's also right. Streams offer limit and skip and so on. So that's also possible within streams. I think it comes a little bit later. So let's move on. So this could also be a great solution, a flat map and a map. And most of the times, some people doesn't know how to use map and flat map. And the point is, map stands for map the result to a different result type. So let's imagine we have a list of users, for example, and I only want to have a list of integer values of the user IDs. Then I would choose the functionality of map, because I would say DB root get users, stream, and then I would say map, and then I say it's the same like in that case, c.get ID, for example. So that means map the result to a different result, or map the collection to a different result type at the end. So then I use the map mechanism, and the flat map is quite similar, but you will use the flat map always on multiple objects. If there is an additional list within another list, for example, here we have all authors, we stream through that authors, and then we say, give me just the addresses of the authors. And in that case, then we say flat map, and this converts the result to a list of addresses. And this is how we get just the essence addresses of the authors. And this is the differences. You use map on single values, example for author or an ID, or to get a list of single values, and the flat map on multiple additional streams as sub-entities. So like in that case, addresses. Sum and group by, that could also be helpful. I did not use that often, but sometimes it makes sense to have a group by. We had that question how to handle map and hash maps. This could also be a great opportunity to create maps and hash maps on the fly based on a stream. With the group by mechanism, you will be able to group a list to a map later on, maybe to count the value of books by a specific author, for example. Yeah, I think it doesn't make sense to learn that, or to, how to say, auswendig lernen. Okay, so some specific stuff, sorting options, we are able to sorting and collect, and many possibilities. And I'm looking for, oh, I forgot the limit stuff. Okay, sorry about that. I have to add this, but this could be a helpful summarization of the streams, and there are many more, I'm pretty sure. And with that knowledge of streams, now we can move on within our project, just to add some more code on get cars by model, for example, or get cars by brand. And let's see what we can enter here. So we want to have all cars by model. That means let's stream through the cars. Let's say db.root.getCars. Now we have the keyword stream.filter, and we have to define the car. So that means, let's say C for each car, and the C.get cars by model, model.equals model. And then we have to add the collectors, and therefore we say collect, and the collectors dot to list. That's it. So if we split up that a little bit, it will be more readable. So we could say stream, filter, collect. It's always these three parts are most of the time part of a stream itself. And let's say, okay, db root get cars, stream through that, use that filter, and then after that collect this to a list. And this will return cars by model. And I think it's the same down here by brand. So let's say db.root.getCars again. Then I say stream dot filter, C for cars, car.get a brand dot get name dot equals brand, I guess. And we need the collect statement at the end, collectors dot to list. That's it. Okay, any questions so far? So that just to summarize that, the Streams API is really essential for EclipseStore, because it provides the possibility to search for data within Java collections. It's a really great API, and yeah, everyone should be aware of that. Yeah, that's important, I would say. Okay, let's just check it out if this is working as expected. So let's start the application. Try to find my BMW again. So I will use the browser for that. And that's a query value, so should work like cars/by model. Hopefully that will work. Just a second. It's my postman. Just to be sure, this is the okay. Yeah, better to buy a model, and then this is what I 330, I guess. So this should be the right result at the end. You see, when I access the data for the first time, my EclipseStore is automatically initialized, and this is the result of my query or my Streams API. Okay. So, any questions so far? So then I would say I just want to explain this in a little bit all over two mechanisms of EclipseStore that are quite important, and we also get most of the questions. The first one is how to handle the lazy loading stuff. We talked a little bit about that, but a little bit more in detail. There is a presentation that I want to go through. So, okay. I clicked on that link. Okay, I see. Yeah. Why lazy reference are basically important. As we said, EclipseStore is an in-memory database framework, and that is also the reason why it is that fast and that performant. But and yeah, that means the best performance you get when the data is inside the RAM. But in some cases, it's impossible to hold all the data inside the RAM, especially when binary data comes into play. This is a big point. Whenever you have to store photos or binary files or some data or some blobs, then you should always use the lazy mechanism. And sometimes it's just unnecessary to hold all the data inside the RAM. This is also a big point. Many people ask us, oh, okay, we have a database. It consists of 4 terabytes of data. And the first step when we talk about that huge amount of data is, do you really need 4 terabytes of data all the time? Or what is that 4 terabytes of data consists of what? Is that archive data or no? They said most of the time they said no, it's the data from the last 20 years of the application. And then next question is, do you really need the data? And they said maybe not. And then the next step is, okay, are you able to archive some of that data? And most of the time we are able to shrink the data to a good amount of data to handle it within MicroStream. I think that's a really important point. But especially for people for data which is not necessary to have it all the time, you can use the lazy mechanism. And as I said, everything below a lazy reference stays at the hard disk. That means the basic behavior of Micro or EclipseStore is that. So when let's say we have 100 million objects within the object graph, and you start up EclipseStore, these 100 million objects are loaded in the RAM. That's the basic behavior. But when we set some lazy points, let's say on 1 and 4, and this one, for example, then you will only get this data. And I think that's wrong. Also, the 2 here will not be loaded. So because the 1 here is lazy, and everything below that point stays on the hard disk and is only be loaded when we access the lazy object with the get method. Okay, there is one question. Is the EclipseStore cluster needed for a replicated monolith where the second replica is only a failover? Let me just try this. Oh, cluster needed for a replicated monolith? It's only a failover. I would say yes. Yeah, because in that case you will need not sure, maybe. I think it depends. So I would say, but you need data replication in the background, so you have to provide the data to another pods, I would say, or to different nodes, and then you need the data replication in the background, and this is part of the cluster. Yeah. And you also need the load balancer before and stuff like that. So yeah, you will need the cluster solution. Okay, but back to lazy loading. As I explained, the lazy nodes stays on the hard disk. Yeah, that's important. Just to summarize that a little bit, when to use lazy loading: always on blobs, documents, images, and so on. Always on huge collections. So as I said, logs and archive data and stuff like that. This is the special point with less frequented data. So it makes no sense to load data lazily if this data is loaded anyway, because most of the users are accessing this data. Then it makes no sense to have it loaded the lazy way, because it's in the RAM anyway. So that makes no sense. The more, so as I said, the more concurrent user you have on the data, the more it makes no sense to have that loaded lazily. Sometimes it could be helpful to use lazy on huge amount of sub-entities. So for example, if we have a user object or a customer object, which consists of a lot of data below that customer, orders and products and stuff like that. And yeah, whenever you want, if performance isn't that important, and RAM is limited, yeah, then you can use lazy loading. This is one example to have that for especially blobs. So we usually do this in this way. So we have a hash map with a string. The string consists of I would say an index to search for something, maybe the name of the file, or some more information where you can stream through to search for a specific byte array. And in that case, you should use the lazy reference. For example, a huge amount of sub-entities. This is a good solution, especially when you have a list of persons or archive data, which is not that huge, but it's not needed to stay in the RAM. And if it's not a problem when you search for something within that list, to load the whole list at once. So this is exactly what happened when you try to stream through the list of books here in that case. When you call books in that case and say get, then the whole list will be loaded at once, of course, to stream through. And this is so that's why I would only recommend this when it is a list which consists of, yeah, and let's say medium-sized collection or low and medium size. It depends on what kind of entities in it and how many entities are in that. Okay. There is this could be also interesting. There is a clear mechanism, so that means there is an algorithm that works in the background and decide what kind of data which is lazy loaded at the beginning or was loaded, when to release that. At the moment, there is a timer. The default mechanism, I guess, are 30 minutes, and after 30 minutes, the object will be automatically released, but you will be able to adjust this or to configure this at the beginning or on startup of micro stream. So that means it depends on you. Yeah, you see that here. So duration of 30 minutes. And there is also a mechanism where to say, okay, if we reach 75% of the memory, then most of the lazy loaded data should be cleared. Okay, that's just a small overview to lazy loading. And there, the second point I want to talk about is the legacy type mapping. And that means what happened if data changes. So for example, what happened when, for example, when I changed the brand in that case, what happened if I add something? And we call that, or just let me, before to get into that legacy type mapping, let me just check if there are some questions. I remember Eclipse stores incrementally. Can you explain how, when a garbage redundancy wipe is done, lazy loading makes that really challenging? I'm not sure if that is wrong. Eclipse Store doesn't stores incrementally. So because Eclipse Store stores whenever you call a store method, then data goes directly to the database or to the hard disk. But there is one point. I think there is a difference between garbage collection and redundancy wipe or lazy loading clearance, I would say. That are different points. So there are three types of garbage or garbage collecting data. The first one is whenever you delete something within your storage. Let's say we have a lot of customers within a collection and you say, okay, collection.clear, and then you store the collection. It needs a little bit to that the garbage collector clears the references from the storage itself. That I think that's the real garbage collection. Then there is a second one, which is also called garbage collection. It's whenever you let's say you store one or you update an entity for 20 times, then you have 20 times the same object attached to the storage itself. And this is the second process to clear the duplicate entries of the storage. We call this housekeeping. And this is the second part. And then is a third part. It's the clearance of lazy loading stuff. And we call this, it was part of the presentation. Come on, can't remember this. Lazy loading. Just a second. yeah, lazy reference manager, or this is it was yeah, lazy reference manager. And the lazy reference manager takes care about clearance of lazy entities. And these are three different types of garbage collecting. And you are able to adjust the amount of CPU and the amount of or the, let's say try to find the English word for that. The amount of CPU and how often the garbage collection is running. And in some parts you have to adjust this, but this is also part of the advanced training. And especially when you have a database which collects measurement data or some data from machines or stuff like that, and you get data in a really high frequent way, then you have to adjust the garbage collection a little bit, because they need more CPU and they have to work much often to clear to clean up the storage itself, I would say. I hope I explained it in a way you understand, but yeah, this is part of the advanced training, and there are some further PowerPoint presentation to make that more clear to you. And I have also prepared an example for that. But this is part of the advanced training. Hopefully that answers the question a little bit. I see that EclipseStore is very tight included into objects. Is it possible to encapsulate only into a repository to make the lazy stuff from outside without changing the logic and have only pointing to, for example, to have a Postgre repository and an EclipseStore repo where I can switch if I like. Okay, that sounds to me like then is EclipseStore kind of like a cache for your PostgreSQL database, right? It sounds a little bit like this, like a cache. Not sure if I get it right. So yeah. Okay. Yeah, I think that's yeah, that's right. So yeah, we do that for yeah. I think that's one use case for whenever you need to store data in a lightweight way. Yeah, not sure if I get it right, but maybe we can talk about that afterwards. Okay, so last topic for today, and is as I promised, the legacy type mapping. And in my opinion, it's important that you understand how it is, how it works to change data, and because in some cases that could go wrong. And let me explain that a little bit. Okay, so let's start here. So we realized at the beginning, we thought about, okay, when something has changed within a Java class, for example, on startup, we do all the refresh and we do all the new stuff. But yeah, when you think about that, you might say, okay, that will not work. When the database grows and grows and grows, it will take forever to update everything. And therefore, we decided to create a mechanism which is called legacy type mapping. And it's kind of like a versioning. That means you remember the persistent type dictionary. So, and whenever we create or we change something within a class, a new object is born within the persistence type dictionary. That means, especially when we have a look on one already existing project. So we use the basic example here. So, and if you remember, we looked into the persistence type dictionary here. And when we scroll down, you see there is that customer object, which is defined within MicroStream. Now let's change that customer object a little bit. So let's add an additional private, let's do an integer. Let's call it value. That's totally okay. Let's start the main class. So run as Java application. Okay, so let's check the dependency, the persistent type dictionary again. And you see there is another type created. It's the newer one. So that means it creates another data type with a separate object type ID. And this type contains the new value. And then we have, whenever you touch an old one, it will be converted to the new one. That means, and will be converted automatically to the new one. And this is how basically the legacy type mapping works. So it's a versioning. All the types and all the data stays the same as long as they are touched and saved. And at that time, the object will be transferred to the new one. This works great for many different opportunities or for many different data types. So most of the data types we are able to handle automatically. So that means there is a heuristic in the background that analyzes the data and says, okay, as you can see here, name it's a string. It contains name. It is on the same line of code. And MicroStream says, okay, name could be changed to last name, for example, and by a value of 75%. It's a good chance. And this is the heuristic that works in the background and that do a really good job most of the time. And there are some changes that cannot be handled automatically. For example, convert data type integer to a string, for example, or something really special. But I would say in that case, you have the same issue on any other database on the market when you try to convert a string value to integer or stuff like that. Then you have to create a second or another field, I would say, within your class, and then you have to convert the data, start up the database, copy the data, and delete the old ones. So, but the basic legacy type mapping works as explained, so as a versioning, and whenever an object is touched, it will automatically be converted. And it's also possible to define this by yourself, so that you can specify that in this class, in this version, name is transferred to last name, and then you defined it, and then it is like that. Okay, let's just this is more stuff for the advanced training. Okay, it's 50 minutes to 9, and I think it's time for your questions. I think that's all from my side to the fundamentals training. Let me just summarize that a little bit. We talked about how EclipseStore works in the background, how to initialize the framework. We talked about lazy loading. We talked about the proper data model and stuff like that. You have access to all the GitHub repositories I share that with you. And yeah, any questions from your side? Okay. So then let me say thank you for your attention. It was a great pleasure. Hopefully we see each other on the next advanced training. I wish you great success for your proof of concept with EclipseStore. Whenever you have questions, feel free to contact me directly, send me an email, or use our support line. If you need a certificate, let me just share the link where you can. Where is it? Fundamentals training. So this is the link where you can fill the form to get a certificate. Hopefully this is the right one. So let me just double check. Yeah, it's the form for April the 26th, but it will also work for this training. No worries. Yeah, creating backup it's an interesting point. There are two built-in backup solutions within EclipseStore. One is kind of like, we call it mirroring, or it's a continuous backup. That means whenever you store something within the storage, there is all the time a second storage is written in the background. So it's kind of like a mirror which is created all the time, and every store goes also to the mirror. This is the first stage of backupping stuff, and there is of course a full backup solution. Some people ask all the time, why not just copy the stuff from the hard disk? But you have to consider that the storage manager always write data to the files, and when you copy the file during the storage manager accesses the file, that could be a problem. And therefore we integrated a full backup within the microstream or EclipseStore thread that helps to create a full backup of your storage. Yeah, but this is also stuff for an advanced training. But just for you to answer the question.